So there are many ways to organize and visually display data. Sometimes it's helpful to organize numeric data into intervals. The frequency of an interval, so basically what that's saying is how often that interval occurs, is the number of data values in that interval. So we can use a frequency table to group a set of data values into intervals and show the frequency for each interval. Intervals in a frequency table do not overlap, important information, and do not have any gaps, okay, and are usually of equal size. So for step 1 here, we're going to go ahead and make a frequency table. This will be important later whenever we actually start compiling this data to create a histogram. So the number of home runs by the batters in a local home run derby are listed below. What is the frequency that represents the data? Use intervals of 4 and then use intervals of 5. So if we're looking here, we're going to start at 0. And if we're going to use intervals of 4, we're going to say, well, 0 is 1, then 1, 2, 3. So we're going from 0 to 3. Okay, then we're going to start at 4 and go from 4 to 7. We have 4, 5, 6, 7. So that's 4 intervals. Then we start at 8. And we're going to go to 11. Then we go to 12. And we go to 15. And then we have 16 to 19. So those are our intervals. Now we have to look at our actual data, which is all of these numbers up here. And we're going to say, okay, so from 0 to 3, how many numbers range from 0 to 3? So we're looking at numbers like 2, because that's in between 0 and 3. We're looking at numbers like 3. 4 would not qualify because it's not in between 0 and 3. So we only have 2 numbers that are between 0 and 3. So that's going to be our frequency. Then we have 4 to 7. So let me change colors here. And let's look for numbers that are between 4 and 7. So we have 7. We have another 7. 5. 4. And we have another 7 here. So how many numbers are between 4 and 7? We can say there's 1, 2, 3, 4, 5 numbers that are between 4 and 7. Change colors again here. This time we're looking for numbers between 8 and 11. So we have 9, 10, and those are only 2 numbers between 8 and 11. So we have 2 numbers. Let's see. We'll go pink. So then we have 12 to 15. So 14 is between those. 12, 12, and 15. So we have 4 numbers that are between 12 and 15. And last, we have 16 to 19. Well, we only have 1 number left at 17, and that is between 16 and 19. So the frequency of those numbers is 1. There's only 1 number between 16 and 19. So that's our first frequency table. But for the next frequency table, it says use intervals of 5. So I'm going to go ahead and erase this because this is going to change our answers a little bit. So we're going to start again at 0. And this time we're doing intervals of 5. So we're going to go all the way to 4. So 0, 1, 2, 3, 4. Then we go from 5 to 9. 10 to 14, 15 to 19, and then we have 20 to 24. Okay, so we should see a difference in these frequencies for this table and for our second table here. So between 0 and 4, we're going to go ahead and look. We have 1, 2, 3, and it looks like that's it. So we have a frequency of 3. If you look here, we had a frequency of 2 at first, but since we expanded our frequency from 0 to 4, our interval from 0 to 4, we picked up an extra frequency. So then we're looking for 5 to 9. So we have 1, 2, 3, 4, 5. That actually stayed the same. Then we looked at 10 to 14. So we have 1, 2, 3, 4. That went up quite a bit. Then we're looking from 15 to 19. So we have 17 and 15. And we're actually out of numbers. So that means the frequency for 20 to 24, there are no numbers between 20 and 24. So that's just going to be a 0. So that is how we create a frequency table. Like I said, that's going to be very important whenever we go to create an actual histogram. So moving on, it says a blank is a graph that can display data from a frequency table. So we've kind of already talked about that. We can say a histogram is a graph that can display data from a frequency table. A histogram has 1 bar for each interval. So the height of each bar shows the frequency of data in the interval it represents. There are no gaps, again, very important information, between bars, and the bars are usually of equal width. Another key factor here. So the data below are the numbers. I'm going to go ahead and scroll down so we have enough room here. The data below are the numbers of hours per week a group of students spent watching television. What is can't read. I haven't been at school lately. What is a histogram that represents the data? Okay, so one key thing that we always want to check first, it says hours per week, and it says use intervals of 6. So that's very important information. Again, we're going to start at 0, and we're just going to count 0, 1, 2, 3, 4, 5. So we go to 5, and that's 6 intervals. Okay, then we go from 6 to 11, 12 to 17, 18 to 23, and 24 to 29. Okay, so we need to fill out our frequency table. So from 0 to 5, how many numbers are between 0 and 5? So we have 1, 2, 3, 4, 5, 6 numbers that are between 0 and 5, including 0 and 5. Okay, then we look from 6 to 11. So we're going to say 7, 6, 8, 11. 7, 6, 8, and 11, that's 4. Sorry, I didn't switch colors there. Kind of got confusing. So from 12 to 17, oh, I missed one actually. Let's go back here. Let's erase all these. Sorry, I'm going to get us back where we were. Okay, now let's look for 6 through 11. Okay, so we have 7, 10, 6, 8, 11. So we have 5 numbers that are between 6 and 11. Switch colors again here, and we can go from 12 to 17. So 14, 13, so we have 2. Then we can look for numbers between 18 and 23, so that includes 22, but does not include 28, so we only have one of those. And lastly, we have 24 through 29, and 28 is involved in that, so we're going to say there's only one of those. Okay, this is where it gets kind of, well, important to make sure that we understand what's going on here. So our intervals are what's at the bottom, okay? And we're talking about hours per week. So I'm going to go ahead and I'm going to label. Okay, so I usually say between here and here is my first interval. So I'm going to say that's 0 to 5. I'm going to label that. Okay, then we have our next interval. Since they have to be of equal width, we're going to go again. And we have 6 to 11. Again, equal width, so we have 12 to 17 here. Then we have 18 to 23. And our last interval is 24 to 29. So for frequency, since our highest number is 6, I'm just going to count by ones. I'm going to go 1, 2, 3, 4, 5, 6. And you can go ahead and label the rest of your lines just so that it looks like you have a full graph. So for 0 to 5, what we have a frequency of 6. So you're just going to create a bar. Okay, then from 6 to 11, we have a frequency of 5. Create another bar. From 12 to 17, we have a frequency of 2. From 18 to 23, we have a frequency of 1. And from 24 to 29, we also have a frequency of 1. If you want to, you can shade those in. Otherwise, you can leave them blank. It does not matter. It's kind of a preference. Okay, so we have a graph. We have made our histogram showing the frequency of hours per week. Okay, so that's our first histogram. All right, let's go ahead and try another one. So it says the finishing times in seconds for a race are shown. So we have our data. What is the histogram that represents this data? And it tells us again to use intervals of 5. So I'm going to start at 0. Actually, should I start at 0? I don't think so. I wouldn't want to start at 0 because if I start at 0, I'm never going to get to the smallest number we have. And the smallest number we have in our data is actually 80. So I can go ahead and I can start at 80 and go by intervals of 5. So if you start at 80, you have 80, 81, 82, 83, and 84. That would be your interval of 5. So 80 to 84. Then we can go 85 to 89, 90 to 94, 95 to 99, and then we have 100 to 104 for our last our last interval. So now let's look at our frequencies. We have 80 to 84, so let's look and see what numbers are between 80 and 84. We have 83, 80, 82, and 82. So we have 4 numbers that are between 80 and 84. Then we look for between 85 and 89. So if I look, I only have an 89 here and an 89 here. So we have 2 of those. Then we can go from 90 to 94. So that's going to include 93 and 90. So there are 2 of those. And then we can go from 95 to 99. So we have 1, 2, 3 of those. And our last interval is 100 to 104. And we have 2 numbers left that fall between that interval. So we have a 2 for frequency. Okay, from here, we're going to go ahead and start by labeling our graph, we have finishing times for the interval. Okay, and again, I'm going to go ahead and stretch it out where we have kind of two parts here. So we have 80 to 84. Then we have 85 to 89. Oops. Then we have 90 to 94. 95 to 99. And 100 to 104. Okay, since our frequency here only goes up to 4, that's our highest frequency, I'm going to skip a line here. So I'm going to start here at 1, 2, 3, 4, and 5. You do not have to skip lines. Like I said, I just like to fill up the entire graph, but it is completely up to you. So if we look at 80 to 84, we have 4 numbers between 80 and 84. Then we have 85 to 89, and we have 2 of those. 90 to 94, we also have 2. 95 to 99, we have 3. And 100 to 104, we end up with 2. Okay, so again, here you can leave them blank or you can shade them in. It doesn't matter. I'm just going to leave them blank this time. But that is our histogram for finishing times. Okay. Now we're going to actually learn how to describe these histograms. Okay, so if the bars are roughly the same height, which here they're kind of close, but not completely for number 3. But if they're roughly the same height, like shown in this picture, that histogram is said to be uniform. Okay, and then it says if a vertical line can divide, so vertical means straight up and down, if it can kind of divide your histogram into 2 parts that are close to mirror images, so if they're close to being symmetric, then the histogram is called symmetric. If the histogram has one peak that is not in the center of the histogram, then this is called skewed. Okay, now if we go back up here to number 2, whenever we made this histogram, you can kind of see that this is a lot higher, this side over here. So this kind of slants down like that. That would actually be considered skewed because a lot of your data is to one side. Depending on the side, sometimes you can even get a little bit more, you can kind of get your answer a little more accurate by saying right skewed. And left skewed, depending on what side most of your data is on. So like I said, if you look back up at number 2, a lot of your data is on the left side of your graph, which means that that would be a left skewed graph. Okay. So we're going to kind of interpret A and B here for number 4. We're going to tell whether they're uniform, symmetric, or skewed. So if you look at A, I would say this graph is symmetric. If you were to split this graph in half, it would be very similar on both sides. Actually, it looks like this would almost be identical on both sides. Okay, for B, since you have a peak here, this one is actually going to be skewed. And if we really want to get technical, most of our data is on this side of our graph, so that would be right skewed. Okay. I think this is the last one, number 5. Okay, it says the following data shows the number of dollars Jay spent on lunch over the last 2 weeks. So we can say money spent on lunch. And then if you want to get really technical, you can put a little dollar sign there showing that he's spending this in dollars. Okay, so make a histogram of this data. Is the histogram uniform, symmetric, or skewed? So we're going to do the same thing we've been doing, but we are going to go ahead and kind of give a little bit more information by telling us whether what kind of histogram we have. Okay, so this says intervals of 3. Like I said, it's always important to check this information first, just so you know what intervals you need to go by. So, since our lowest number is 1, we can go ahead and start at 1. And then we can go 1, 2, 3. And we'll end up at 3 with an interval of 3. Then we go 4. Oh, I'm sorry, not 4 to 7. 4 to 6. Then 7 to 9. 10 to 12. And 13 to 15. It looks like we're going to have a problem here, though, because we have a number that's greater than 15. So I'm going to just have you guys cross out that 16. Act like that data is not there. Okay. So for frequency, we're going to go 1 to 3. We have 1, and it looks like that's the only number between 1 and 3. So we only have one of those. Then we can go 4 to 6. So we have 1, 2, 3, 4. Looks like we have 4 numbers between 4 and 6. 7 and 9, we have 1, 2 numbers. 10 to 12, we have 1, 2. And from 13 to 15, we have 1, 2, 3, 4 numbers. Okay, so let's go ahead and let's create a histogram for this. Again, our intervals we have from here to here, I'm going to say is 1 to 3. Here to here, we're going to say 4 to 6. From here to here, 7 to 9. Then we have 10 to 12 and 13 to 15. Since our highest frequency is 4 again, I'm going to go ahead and skip lines to kind of spread our histogram out. Okay, so from 1 to 3, we only had one time that he spent $1 to $3. Okay, then from 4 to 6, he spent that 4 times. Whoa, getting crazy with my lines here. See if I can erase that without erasing everything else. There we go. Then we have 7 to 9, he spent that twice. 10 to 12, he spent that twice as well. And then from $13 to $15, he spent that 4 times. Okay, now we're done with the histogram part, but it says, is this histogram uniform, symmetric, or skewed? This one's kind of hard to tell because of the fact that you have from 4 to 6 has a peak, and from 3 to 15 has a peak because it's higher up here. Okay, so really, I would accept a couple different answers on this. I would not probably accept symmetric. Uniform would be the only other one I would accept, but I really would think that this would be skewed. Because you have those peaks. Since there's a peak and it's not common for it to be that high, I would consider this a skewed graph. See if we have any other questions. I don't think we have any other questions here. So that is all about histograms.